Okay, so back to Visual Studio, we'll look at firstly our account controller. And I mean, we could sit and dissect everything that is here, but what I really want to point out are the fact that it does have actions for the login. It does have a get and a post action where it validates who is the person logging in and then takes an action. It's just a bunch of if statements like we're used to. And then you get some other code because remember, it's not all about verifying or validating against a local database, but it also gave us code to allow us to register and sign up for an application using social media accounts. For this video, however, we're going to simply look at controlling registration and login using our own local database and what we need to do in order to support that. Now let's systematically go through all of this code. All right. So the first thing to point out is that in the models folder, you would have gotten some model files, particularly identity models.cs. And this file would be like the initializer for the entire identity engine, which is what controls a user authentication engine, right? Now, this user authentication engine actually automatically creates a database for you, at least if you don't already have one. If you already have one, then it takes a bit of configuration to ensure that you are going to be pointing to the database that you want it to point to. Now, in our model file, identity models, we'll see that we have two classes, application user and application DB context. And application DB context points to some connection string called default connection. What happens is that once you generate all this code and an identity engine, it actually will generate a database for you on the first launch. All right. And this database will be generated based on the specifications set up in default connection. So we can go to Solution Explorer and take a look at the web config file. That's web config at the last one here. That is at the project level. There is another one here in the views level that is not the one you are to be looking at. So the last web config file that is in the project, let's go back to the project. It will have under the connection strings section in line 12, it may vary, but you'll see a connection string here with the name default connection. And if you take a look at what is in the connection string value, you'll see it has a quite unique looking value there. And what it is doing is creating a database that has the same name as your project. And it will use that as the engine for your identity functions. Now, if I take a look at Server Explorer, I'll see that I indeed and in fact do have a database set up, default connection and in bracket school management, and you'll see that it has all of those tables, right? It has quite a few tables, and I added a few tables there afterwards, but don't mind those. You should see at least these. But that is not necessarily what is desired, because we have already been working on our database. We are at this point, because we're doing database first MVC5 development. So indeed and in fact, what should be used to house our identity tables should be our database that we have come this far with, which is housed in the school management _DB entities connection string. And if we look at this connection string, we see that it is indeed and in fact pointing to the database in our local DB called School Management DB. That is the database that we really want to be using to house all of our user interactions or user authentication and the various user-based functions. All right. So the first thing you want to do is change where this is pointing to. Now, I already have that line of code. I did this. All right. And I'll walk you through it. So I'll just comment this line and uncomment this line. And I'll walk you through the changes I made. I took everything out after data source, and then I replaced it with the values coming from the data source here. So I looked in my entities connection string and I scrolled across until I saw data source. So we have connection string is equal to, and then we have data source. And then I took everything here from local DB, right down to the last one. I don't think you need everything, but just to give you some clarity. And then I used that value and paste it here in data source right here. So at least the two of them are looking to the same point. And then you're probably going to ask, so why not just change the connection string that is being referenced inside our identity model? Now, the problem with doing that is we're using entity framework, and identities does not play well with this flavor of entity framework. So it will actually give you an error if you try to replace the connection string that the identity model is using. You can try it and see the error for yourself. And if you've had any success with it that would go contrary to what I'm saying, then drop me a line and let me know, and we can have a discussion about it. But my thing is, I just kept default connection. I could always rename it, but I have to make sure it matches a connection string here in this config file. And then I changed out the value in connection string to point to my database. Now, having done so, once you go into debug mode, it will then search for whatever database. So in this case, since it didn't exist, it actually created this database at the time. And then what it will do, if the database is found, which it will be in this case, is go ahead and generate those tables. So if I look back in Server Explorer and look at all the tables, you'll see that I now have all of those tables created here. And if I look inside of ASP.NET Users by right-clicking and viewing the data, I will see that the user I just created is right here. The ID looks a bit weird because we're probably used to that auto-incrementing. This is what you call a GUID, a GUID, or a very unique ID value. All right. We have the email address and we have a few falses, but look at this. Look at the password. This is not just a password, but it's called a password hash. Look at it. Take a good look at that. It is always good practice to encrypt your password so that if somebody by any stroke of luck got to look at your database and look at a user's record, as much as they can see the email address, they should never be able to make out what this password is. And if you look at what comes up in that tooltip, you'll see that that is the full value of this password. It is completely unintelligible to a human being. All right. And then they have a few other default columns that go in. And you see the username is automatically set to whatever the email address is. All right. So that obtains for every user that you create. You see that they also have support for roles. I don't have any roles. Now let's get back to our model, application user. Now, the challenge with this auto-generated code is that it doesn't necessarily capture all of the data that we want to capture based on our context. So, for instance, I'm doing a school management system. If I'm going to have users, I'm going to definitely need more than email address and password for my users. I'm probably going to want a date of birth for my students. I'm going to want an address for my teachers. I'm going to want additional information. All right. So we need to be able to modify our context or our model that is governing what a user looks like to our application. Now, there are a few changes that will need to be made. And the first one is with application user. So we want to go ahead and add the property date of birth to this class. So I can just write prop in Visual Studio and press tab twice, and that will generate that line. I would want that date of birth to be a date time data type, and I would want it to be birth date. And then I can just use this, clarify that using system in order to get our date time. Do recall you have to use certain libraries to get certain class types. So we now have a new property in our user called date of birth. or birth date rather. So that is modification number 1 under our belt. Do note you add as many properties as you need, and be sure to use the correct data type as you see the need to when you're storing the data, because whatever data type you're going to use here in C# is going to be translated over into our SQL for further storage. So be very, very deliberate with your data types. The next step is to make what you call a migration or a change to the database. Now, we've gone through making changes to the database. We saw that we just need to go into our SQL Explorer, bring up the table, modify it, and then update our EDMX. The problem here, however, is that, well, this EDMX has not been updated to reflect the new tables. And 2, making the change just like that does not necessarily mean that the application is going to know what to do. Now we need to run a migration, and to do that, we're going to have to get our hands a bit dirty with our console, which means this is one of those things you can't just click and generate. You'll have to write a bit of code here to do that. So we will want to write some code to enable migrations and further on effect the migrations using our package manager console. I have it here docked on my toolbar already, but then if you don't have it there or anywhere visible, then you can always go to Tools and then go to New Get Package Manager, and then you just click Package Manager Console, and that will generate this console. So I cleared my console of any messy error that was there. And then we will look at enabling migrations first and foremost. So we will write enable dash migrations, and we press enter. And then I'm actually going to reproduce that error that we just saw. So this error is saying that we can't have a migration being done in ambiguity because I have more than one data context. It doesn't know which context or which database connection. Remember that we had 2 connection strings as told by our web config file. That was the wrong one, sorry. In our web config, we had context number 1, context number 2, or rather we had context number 1, application DB context, as well as context number 2. Do remember that this is a database context in waiting. Enable migrations is saying, I don't know which one you want to use this command on. So we have to be a bit more specific. So they actually instruct you as to what to say. They say use, and they say it for both. So more than one context was found. To enable it for the application DB context, then we need to say enable migrations for this, that. And then if we want it for the entities context, then we need to enable it for that. So I would want it on the application DB context, since that is the one that really and truly we are identifying as our user management data context. So I'm going to say here, enable migrations. I can just press up to see the last command, and then I'll say dash context type name, and I just press tab and it generated that line. And then I'm just going to copy and paste this part to reduce the margin for error, application context DB, and let's press enter and see what happens. All right, so that operation may have taken a while, but then we'll see here that it's completed and we got a new file, configuration.cs. And we also have a tiny warning here saying that they detected that another migration may have occurred, but the end result is that we have enabled it for our project. All right, so the next thing we want to do is actually register our migration. So a migration is pretty much like making a change to the database. You make a change to the database. In this situation, though, we're making a change to the model that is generating the database. So up until this point, we have generated models based on the database. These models are generated based on the database. In this situation, the database was generated based on application user model, which is inheriting from identity user, which is where all of those default tables and columns were generated from. So we actually modified the base model. So we need to inform the database that the model that it should emulate is now updated. And this is a principle in code first development. We're doing database first development. So in code first development, that is how it is. You build the base model and then you generate the database based on that. So in this situation, we need to let our database know that we've made a change or we're going to add a migration. So I'm going to add -migration and I'm going to name it added birth date. That is the name of this migration that I am registering. So I'm just going to press enter. And then this is also going to do a little operation. And when this is completed, you see that you would have gotten another file. And just to take a look at where these files are being stored, you actually got a new folder called migrations. And then you'll see all of those migration files being listed there. So each time you add a migration, then a file is generated just to keep track of the changes that are being made. The good thing about this is that you can roll back to a specific migration in case you think you may have botched your data model or you made a change that was undesirable. You can just roll back your migration and it would undo the changes to your database. So this code first methodology does come in handy when you're dealing with a very dynamic project and you don't necessarily know what your database is until you are developing the feature. So this works well with a more agile approach than having the database and building around the database. That being said, after we get this file, the last thing we need to do is actually update the database. So we say update-database and then press enter. All right, and then we get a bit of verbiage saying that we can say update-database space -verbose, and that would show us all of the SQL statements being applied to the target database, meaning whatever statements would have been used to make that change and add that column. But the end result is we see no red writing, so we can assume that we have no errors. And then we can always go back to our Server Explorer and refresh our table, and voila, there is birth date added to our table. So you can do this with as many other columns as you see fit. I'm just using birth date today as a quick example. Once again, you simply add your column here, or as a property rather, and then you run a migration. The great thing is that you already enabled migrations, so you don't need to go through that step again. What happens hereafter is that each time you make a change, you have to add a migration and tell it a name, what migration was done, and then you run an update command. And that will keep track of all of your changes as you go along, because, you know, your project may expand, it might contract, your requirements change, and you need to be rather dynamic with what you're storing as user information. So that is how you go about customizing this identity model to what you may need in order to complete your task. Now we have about 2 more steps and then we can call this relatively completed. The fact that you added this to the database does not change the view. So remember, although we update the model, we still need to modify our view to be able to collect this information. And there are a few more steps that need to go in order to accomplish this. So firstly, we need to understand where what is stored. So remember, all views are stored in a views folder and in a folder that corresponds with the controller that it is related to. So we have the account controller for user authentication. So we have the account views folder for all views related to that. And then we do have our register page. Now, our register page is what asked us for the username, which in other words would be the email, and the password. And then it asks for a confirm password. Now, as we see, there's some configuration, some generated code in the backend that gives us the the comparison between the password and the confirmed password before it actually accepts that data. You can attempt to have mismatched passwords and see that validation message that comes back. And remember that validation message would come back up top here, or the set of them would come back here. So what we want to do is add birth date as a field. So I already have email. I would probably want to select or collect the birth date right after email. So I can change this to birth date and birth date. But then you would notice that there is no birth date coming up in the IntelliSense because our model does not know anything about birth dates. So I'm just going to put it there, and we see that it has a red line because our model, once again, does not know what birth date is. If we look at what the model is, we'll see another new construct being introduced called a view model. So it's really just a model like any other class that we've seen. It's just that the view model, the principle of view models is that you, the developer, can actually customize a class that helps you to add your own data annotations and validations and so on, and then you pass it on into the database or match it back to the model at will. I would have to do an entirely different tutorial on that view model point of view and perspective, but then let's just bear through this one and hopefully you connect the dots. If not, you can always watch that video. So we need to modify our view model so that the page will know about birth date. So if we just control and click on register view model, we'll be navigated to it, and it is really being housed in a file called account view models. So in Solution Explorer, if we go into models, we'll see that we have account view models. All right. And then if we open that file, we'll see that we have quite a few models, view models rather, that kind of have the same names as some of the views that you would have seen in the accounts controller. All right. So you have verify code view model. You have verify code view. You have forgot view model. If you look in Solution Explorer, you have a forgot password views. All right. So really and truly, a view model is more of a specific type of class that you create, and you can set up your data annotations at will. And you see that there are quite a few data annotations that help with validation and what is displayed. And that gives you greater control over how you generate your view and what you display on it, versus the the model coming back from the database where you kind of have to work with what you get kind of vibe. So this is a far more flexible way for you to, it's a bit more work, but it is a flexible way for you to manage your views. So if we look at our register view model, we'll see that this is required. It's an email address. The display is email. So we all know from our data annotations video that we can change what is displayed here. All right. Email address / username, since they're doubling. All right. So I can say email address / username, and that would change that display. And we have the property email. So what I need to do in order for this view model to know about birth date is add it here as a property. So I will go down. So I'm going to make the birth date mandatory. So I'm going to say required. I'm going to specify the data type. So you have some default ones like this. That's an email address attribute. But this one, I'm going to have to use my data type. I think these are enums. So data type, and then open and close parentheses. And inside of those parentheses, as the parameters, I would say data type dot date time. And you'll see that you have quite a few ones coming up in the IntelliSense. So you have all of those that you can use if you need to add that kind of validation to whatever field you're about to put in. So the data type must be of type date time. And the display will be date of birth. And once again, this is where that display name comes in, because I'm really calling this birth date. So it is of type date time, and it is birth date. And then once again, I have to include the library for date time, which is using system. Now, having done that, the error line will go away because now our model knows what birth date is. And then the final piece to this puzzle is to modify our account controller in our register post action, where it is actually loading up our model to send off to the database. So we say var user is equal to new application user. Remember where application user is coming from. It is the class that we just added birth date to, application user, birth date. So we need to update this creation model, this creation of an object of application user to say username, email, and then I already added it. So that's what it would be, but we don't want it to be datetime.now. We'll just add it on and say birth date is equal to model dot birth date. So remember that once the post action, once we get the view and then it is submitted, it turns over to the post action. The post action is then receiving an object of register view model called model. And in this register view model or model object called model, we are using the corresponding data fields to fill out these properties. So that means I could easily add another field here and call it username. And then instead of using the email address for both email and username, we can say model.username after adding an appropriate text box or collection section for the username. So whatever modifications you're going to make to your application user model, you have to also make it to your register view model, then the register view in order to have synchronicity there, and then finally our account controller. And all of that can't be done without doing these migration steps. So I will actually, in the notes, write out the steps towards filling out or completing all these tasks step by step. If you follow those steps, then you can't leave any stone unturned. Right. So to wrap this up, let us make sure that the changes that we made are, reflecting in the functionality. So once again, I made a change to data annotation. So I said email address / username. No two users should ever have the same email address or username. If I try to register, then we will get something about the date of birth field being required because we set up that data annotation, and the passwords do not match because there's also generated code or annotations that govern that. So all of those things are in place. The date of birth, really and truly, you want to use a calendar picker here. You don't want to have date of birth just being a free text field as much as it's a date time, and it will not accept that. But then users will try to type in the date according to how they think a date should look. Because some people say year, month, day. Some people say year, day, month. Some say day, month, year, etc., etc., etc. So you want to use a calendar picker and force the standard from right here as much as you can. But I won't go into that right now. I'll just write a very generic and random date. And I will use a password test password. And it's worthy of note that you can use data annotations to actually govern how strict these passwords are. I think that's a mismatch also. Let me check. There, that is a mismatch. So type in a password and then press register. So let us actually click register and see what happens. And then it gives us that standard about that password. So let me try that again. Test. So the password is capital T, capital P, test password 1. All right, so we have at least one digit and we have at least one uppercase. I gave it 2, so we shouldn't have a problem now. All right, and we see that we progressed beyond that checkpoint. And if we take a quick look in our database, I'll just quickly bring up our Solution Explorer. Drill down into our tables. into our databases and then into our tables. And we look at the data in ASP.NET users. And there we have it. We have the user that was created earlier, and it got a very generic birth date because the birth date field can't be null. And we specify that in our database design. So it's not null. And so it got a very generic birth date. And also we see here that the one we just created actually got the birth date that we put in. All right. So those are things that you can do to make sure that you're capturing all of the required fields according to your context and application, and customize the ASP.NET user identity engine. All right, so thanks for watching, guys. I hope you learned a lot. Once again, if you are unsure about anything, drop me a line in the comments and I'll be sure to get back to you as quickly as possible. And in the next video, we'll be looking at how we can go about restricting access to certain parts of our application.